Looking at statistics section 3, mean, median, and mode. Measures of central tendency is a statistical term that refers to the values that best describe the center of the data set. And we have 3 such values. They are mean, median, and mode. So the mean is the most commonly used measure of central tendency. It's also known as the average. So if you've ever found your average grade in a class, or the, I don't know, you've probably used average, maybe the average amount of money you spend a month, I don't know. But most likely somewhere in your lifetime you've computed an average. What you might not have known is that the average, in statistics, we have a different symbol for a sample average as opposed to the population. I wouldn't worry about that too much for this class, but I do want to specify that if it's a sample, it's x bar, and it's equal to the sum of all the x's divided by n. So I'm going to grab a different color here. So the little weird looking E thing, it just means the sum of the data. And the n is the sample size. But if you're looking at the mean of the whole population, that's represented with the Greek letter mu, which looks like a U. And it's the same exact formula. This is the sum of the data. And then this is the population size. Don't worry about that too much, but the reason that I did want to mention it is because when we calculate standard deviation later on in the course, we're going to be using that x bar. So for now, just remember that x bar is your mean. To compute the mean, so example 1, we want to compute the mean of the following data set. So we're going to take all of those values. Oh, let me switch back to purple. 12 plus 15 plus 17 plus 18 plus 18 plus 19. Add it all together. And there's 6 pieces of data, so I divide by 6. That equals 99 divided by 6, which is 16.5. So my x bar is equal to 16.5. Using a frequency table. All right, so I'm going to do it the long way because I think that makes more sense to people. So we've done frequency tables before. So the number of siblings is 0, has a frequency of 5. So that means I'm adding 5 zeros together. There's 13 ones, so I need to add 13 ones. I was counting them in my head and I wrote 12. I think that's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. There are 6 2s. And 3 3s. And 2 4s. And 1 5. So you would add all those together. And the sum of the frequencies, so the total, is 30. I would add all that up and divide by 30. But the quicker way of doing this is instead of writing 0 plus 0 plus 0 5 times, this is the same as 0 times 5. 1 13 times is the same as 1 times 13. This is 2 times 6, 3 times 3, 4 times 2, and 5 times 1. So the more convenient way of doing this would be to write 0 times 5 plus 1 times 13 plus 2 times 6 plus 3 times 3 plus 4 times 2 plus 5 times 1, and divide it by 30. That comes out to be, if I've done my calculation correctly, 47 over 30, which is 1.5667 rounded to 4 decimal places. So this one is probably a more challenging mean problem because a lot of students don't notice or don't recognize the frequency table and what it means. So hopefully this helps with that. All right, part 2 is the median. Median is generally just the middle of the data set if you put them in order. And the median splits the data set evenly in half. Before you find the median, though, your data must be sorted in ascending order. That's very important. So the formula, median formula for odd number of data values is super easy. The median equals the middle value. But if you have an even number of data, then you need to take the average of the two middle numbers. So example 1, we have 7 data values, so that is odd, makes it easier. We want to write them in ascending order, so 5, 5, 6, 13, 14, 16, 20. And then we locate the middle number, so we have 1, 2, 3 on this side, 1, 2, 3 on this side. 13 is the median. In example 2, we have an even number of values. And if we put them in order, it's 58, 64, 71, 79, 82, 84, 85, 93. Okay, so if we do the little hops again, I go 1, 2, 3, 4, 1, 2, 3, 4. So I end up in the same place, but not in a number. So I need to take those two values that I landed in between, add them up, and divide by 2. So we had 8 pieces of data here. Yeah, so it's going to be the 4th and the 5th are the two middle numbers for 8. And that comes out to be 80.5. So the median equals 79 plus 82 divided by 2. The difficult thing with the median is just organizing the data in ascending order. All right, here's back to this frequency table again. So if you write all of these in order, so there's 5 zeros. And then 13 ones. 6 twos. Uh-oh, I didn't give myself enough space. Let me start over. All right, 6. And 3 threes, 2 4s, and a 5. All right, so I know from before that there's 30 pieces of data with this one. So we're going to go to 15, which puts us right here. That's the middle. It's hard to see it. That's why I like doing the hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3, 4, 5, 6, 7, 8. Ah, the iPad messed me up. Oh, now it switched to erasing for some reason. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I might have circled the wrong one, so let me just get rid of that because I don't know. 1, 2, 3, 4, 5, 6, 7. Oh my gosh. Stop erasing things on me. All right, so if I count 14 over and then we go one more, because 15 is half with both of them, we end up between these two ones. Which two ones we end up between doesn't really matter. And you might be thinking, well, this is a little tedious, and you're right. But let's go ahead and find the median anyway, now that we've got the middle two. It's 1 plus 1 divided by 2, which is 2 divided by 2, which is 1. Okay, part 3 is mode. So mode is the outcome that occurs the most. There can be no mode, or one mode, or multiple modes. Mode is the only measure of central tendency that can be found for both quantitative and qualitative. That's interesting. Find the mode of the following data set. So there's 3 5s in that one, and there aren't any other values that go over 3. So 5 is our mode. In B, there is no mode, because there's no value that occurs more than once. And then C has multiple modes. Let me get my highlighter. 82 happens twice, and 85 also happens twice. All the other data values only happen once, so there's 2 modes, 82 and 85. And then this frequency table again, but don't worry with mode, it's super easy. You just look at the one with the highest outcome. The mode is 1. And then part 4, we want to find, it's determining when to use different measures of central tendency. So in some cases, the mean is not the best measure of central tendency to use. These are the cases where extreme values that cause the mean to be pulled away from the middle of the data set. So this is getting a little more advanced, but bear with me. We have a class of liberal arts students took a quiz, and their scores are represented in the data set below. We want to find the mean and the median for these quiz scores. So the mean is adding them all up, and there's 15 there. So the mean, or X bar, turns out to be 1313 divided by 15, which is 87.5. So you can do that with your calculator, add them all up, divide by 15. For the median, I have to list them in order. Which I have worked on a little bit ahead of time so that you guys wouldn't be bored. So I'm just listing them all out. 95, 95. Oh, I always do this. 96, 96. And there's 15, so it's even. It makes it nice and easy. This 89 is the median. Okay, so the mean is 87.5, median's 89. Those are pretty close. I would say that this is a pretty good set of data with no extreme values. However, suppose there was one more student in the class that didn't take the quiz and therefore got a 0. If we recalculate the mean and median with the score of 0 included, what will we get? Well, x bar now would still be 1313, but divided by 16, because now there's 16 pieces of data. And that, my friends, comes out to be 82 point, I'll just say 0.1. The mean, however, or sorry, the median, if I pop a 0 in there, I'm going to put it on another color, then my two middle values are 89 and 89. And if you average those, you still get an 89. So the median doesn't change. In this case, it could change a little bit because remember, you're taking the two middle values. So I'm just going to make sure that I counted that right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I end up between those two 89s. Median was not affected at all, but the mean changed quite a bit. So that's all I want you to notice in part C. How did the mean and median change when the missing student score was included? So the mean went down quite a bit. However, the median stayed the same. So what I want you to take away from that is when you have outliers or extreme values, the median is a better measure of the middle.